Here the question says a disk revolves in a horizontal plane at a steady rate of omega as 3 radians per second. A coin when placed on the disk at a distance of 20 centimeter from the axis of rotation, which I assume is the center of the disk, it just starts to slip, which means we know that the particle or a body, whenever performs circular motion, it experiences CFF. Here, because the coin is placed on the disk, it will also have friction to prevent the sliding because of the centrifugal force. Now, since here it just starts to slip, I can say the friction is just balancing CFF. Now, since the friction is just balancing, I can say it has to be F max, which means it is mu n, and the centrifugal force must be m omega square r. Now, we very well know the normal reaction is going to be perpendicular to the disk, which is outwards, and the weight should be inwards on the piece of paper. So I can say normal reaction is just balancing the weight, which means mu mg is m omega square r. Now m gets cancelled. Since we want the value of mu, we can rewrite this as omega square r by g. Now here there is a small correction. In the question they have given that it rotates or revolves at a steady rate of 3 radians per second, which is wrong information or a printing mistake. You can say the omega is actually 2 pi into n, where n is 3 rps and not 3 radians per second. So this is a small correction you need to pay attention to. Now once you substitute this, you can say omega square is going to be 4 pi square n square into r by g. Now in the question they have also mentioned that you can consider g as pi square. That means I can cancel g and pi square, which means 4 into 3 square into radius, which is 20 centimeter. I'll consider it as 0.2 meter. That makes it 9, 4 9s are 36, 36 into 0.2 as 7.2.